Are we live? All right, we are live. Okay, right triangle trig. Okay, so real quickly, everything starts from the angle. Okay, everything starts from the angle. So I'm just going to label this, but let me put a theta. Let's put theta as our symbol for angle. Okay, so today we're talking about right triangle trigonometry. Everything starts from the angle, period. So you go to the angle, and this theta is the symbol for angle, okay? So what I like to tell kids is that this is like a big triangular lake, because sometimes they get really confused where the opposite side is. But if you're sitting here and this is a lake, you throw the rock to the opposite side. Does that make sense? This has to be the opposite side. If I'm standing over here, then this would be the opposite side. Does that make sense? If you walk around, you're right here, then that would be the opposite side. So right now, let's go opposite, right? The longest side already has a name. Only in a right triangle, it has the name of hypotenuse, right? Longest side of the opposite 90 is hypotenuse, only in a right triangle. And of course, this side doesn't have a name, but it's right next to you. If you're standing here, it's right next to you. It's called the adjacent side, okay? So to find the following trig ratios, it's a ratio. A ratio is a fraction, okay? And the ratio of sine is that it is the ratio of the opposite side or the hypotenuse. Okay. Now, before I get going too far, think about this triangle. I just want you to watch. If the opposite side gets smaller, think about the side, then the angle gets smaller, or vice versa. If the angle gets smaller, the opposite side gets smaller. So there's a ratio between the opposite, hypotenuse, and the angle. All three are related. You guys agree? And that's why you get this function. Okay, now cosine, same thing. As the adjacent side changes, it changes the angle, or vice versa. So with cosine, it's the adjacent side or the hypotenuse, right? As the adjacent side gets smaller, the angle would get smaller, right? Now, tangent's a ratio between the opposite side and the adjacent, and they are definitely related. If one changes, it changes the angle. So tangent is the ratio of the opposite side over the adjacent side, okay? Now, cosecant, I did not make this up. I don't know who did, but cosecant is the opposite of sine, not cosine. Again, it's confusing because you think cosecant goes with cosine. It does not. It goes with sine, okay? So cosecant is just the reciprocal. It's just the equal to the hypotenuse over the opposite, okay? These are not used very often. Cosecant, secant, and cotangent are rarely used because you don't need them. You just need these three. But anyway, it's a ratio. And the secant, you'd think the secant would go with sine, but it does not. Secant goes with cosine, so it's the inverse or the reciprocal of cosine. So secant is going to be the hypotenuse over the adjacent. And then finally, cotangent, that kind of makes sense. That goes with tangent, right? I mean, that does make sense. So it's going to be the reciprocal. So it's going to be the adjacent side over the opposite side, okay? So these are ratios, right? Ratios are fractions. Let's take that information and let's take a look at example 1. Okay, so I'm going to slide it up to example 1. Find all 6 trigonomic ratios for theta, okay, from triangle ABC. So one of the things I can do to help myself out is this. This is my theta. 12 is my opposite side. You guys agree with that? Okay. Directly up. Throw the rock to the opposite side of the lake. My 13 has to be my hypotenuse because the hypotenuse is the longest side. It's also opposite the 90. And the 5, you're sitting right next to the 5, so it's the adjacent side. So I need all 6 ratios. I need the sine of theta. I want the cosine of theta. I want the tangent of theta. I need all 6, so therefore I'll need the cosecant of theta. I'll need the secant of theta. and I'll need the cotangent of theta. How am I doing so far? Okay. I'll let you catch up. So the sine, well, according to this, it's the opposite over the hypotenuse, right? So my opposite is my 12, and my hypotenuse 13, so it's just 12 over 13. We're not going to solve because we're asked for the ratios, okay? So we just need the fraction, okay? We're not going to solve. We'll solve an example 2, okay? That's it. That's all I need, 12 over 13. Cosine, which is the adjacent over the hypotenuse, right? So we're going to go just 5 over 13. We just need the ratio. We're not going to solve it. We're just going to leave the ratio. Tangent, which is the opposite of the adjacent. So we're going to go opposite, which is 12, and adjacent is 5. It's just 12 over 5. Now these three get easy because they're just the reciprocals, and I lined them up on purpose. Sine with cosecant, I did that on purpose. Cosine with secant, I did that on purpose. And tangent and cotangent, I did on purpose, right, to help us out. So 13 12. It's just the reciprocal, that's all. Secant is just 13 over 5. And tangent to cotangent is 5 over 12, okay? How am I doing? Now, so what? Who cares about right triangle trig? Except for the fact it is the most used mathematics. I'm not talking about arithmetic, but the most used mathematics. Because we live in a world where you can find right angles everywhere, okay? So if I want to find the length of AB, okay, let's just call it X for now. You guys okay with X? You can call it AB if you want to. So if I'm going to solve for a right triangle, the first thing I have to do is find an angle. Find an angle. Boom. Find angle. So first thing, find a known angle. First thing I'm going to do is find a known angle. Okay, 34. And then I can, from my angle, you come up with the names, right? We need names. Now we need names. Now we're not talking about names. I'm talking about, you know, like this. I'm looking for these kind of names. Opposite, adjacent, hypotenuse. I'm looking for these names. So that the 5 is my opposite side. And what I want to find, which is my X, is my hypotenuse, okay? The adjacent, I don't need the adjacent. I'm not asked to do the adjacent, right? I mean, all I want to do is find the value of X with what I have. Okay, so now what I have is opposite hypotenuse, opposite hypotenuse. So now I need to use the correct trig. So let's set up a trig ratio. All right, well, which one is it? Opposite hypotenuse. Luckily I have them up there. Opposite hypotenuse, which one's it got to be? Opposite hypotenuse, which one does it have to be? Look up above or look at your notes. Sine, right? Good. Thank you for not saying sin. That's for church. Okay. All right. Good. Okay, so we're going to go sine of theta is equal to my opposite over my hypotenuse. Good job, Alan. But instead of sine of theta, theta is my angle. So I'm going to put 34. My opposite is my 5. I'm going to put my 5 there, and my hypotenuse is my x. So I'm just going to put in what I need to. So sine of 34, because that's my angle, theta is equal to my opposite, which is 5, over my hypotenuse, which is x. Okay, now I got to solve for x, right? So if I multiply up the x, right, I'll have an x, my x times my sine of 34 equals 5, okay? Now we're not going to get too confused about this because that's a number. It's just a number in my calculator, right? So I'm just going to divide, right? That's just a number, x times something. So I'm just going to divide. So my answer is going to be really x equals 5 divided by sine of 34. And I'm going to use my calculator. Everybody have a calculator? Everybody need to grab one? If you need to grab a calculator, you will need a calculator. Now, the biggest thing before you do anything is your mode. If you are in radian modes, which we'll talk about radians, you're going to get every question wrong. So if you are in radian modes, these are degrees, right? You're going to do it right, and you're going to get every question wrong. Don't have radians yet. Keep it in degrees, okay? So then I'm just going to go ahead and type it in. I'm going to go 5 divided by sine of 34. Your phones will do these, but it's a little bit harder in your phones. And I get about 8.9. Does that answer make sense? And again, does 8.9 make sense? It does. That makes sense. If that's 5, that could be 8.9. It's supposed to be longer, okay? Thumbs up. Okay. All right, turn the page. Okay, we're going to run out of room if I don't get movement. That's okay. All right, so example 2. Find the measure of theta. All right. Well, again, go to your angle. Well, I'm at theta. Theta's my angle. And then give these sides a name. These need names. This needs a name. What's the name of that side? Don't say 8. What's the name of that side? Opposite, right? This side needs a name. Don't say 10. What's the name of this side? Good. Okay, look up on the board. Opposite adjacent. Which one's it got to be? It's going to be tangent. Tangent of theta is equal to my opposite over my adjacent, because that's what I have. But let's put some numbers in. Now, we don't know theta, so we're going to leave it. That's what we want to find. So I'm going to go tangent of theta equals my 8 over 10. Okay. Now, it's been a year. It's been COVID. So what we push in our button, if we want to find an angle, find an angle, you're going to push the trig, it's called inverse button, okay? You're going to push the trig inverse button. So when you find an angle, you're going to use this button here. So we're going to use tangent inverse of 8 over 10. Always, always, always. When you want to find an angle, you have to use the inverse button. So, looks like this. It's in blue. In my calculator, it's in blue. So I go second tan, okay? And I get that inverse of 8 divided by 10, about 38.65 degrees. Okay, again, does that answer make sense? Well, yeah, it's an angle, right? Okay, 36.8, or 38, my bad, 38.65 degrees. Okay, I'm going to skip 3, because I'm running out of time, and I'm going to take a look at 4, okay? Okay, so a man sights the top of a building at an angle of elevation of 65. Okay, angle of elevation, right, of 65 degrees, except there's one thing we got to be careful with, and that is the man sights the building, he's 6 feet tall. So really, the triangle I'm looking at right now is this triangle, because he's 6 feet tall, right? So when I get done with this problem, I better add his height in, okay? When I get all the way done, I'm going to add in the 6 feet. Okay? Now if he's 50 feet from the building, let's see what I have. Okay? I want to find the opposite. I know the adjacent, right? I want to find the opposite. I know the adjacent. I'm going to set up tangent, right? Opposite adjacent of my opposite over my adjacent. So I'm going to go theta. Theta is my angle, which is 65. My opposite is what I want to find. My adjacent is 50. I want to solve for x, so I'm going to multiply up the 50. I'm just going to bring it right up there. So I'm going to go 50 tangent 65 equals x. Use my calculator, just going to type it in. 50 tangent 65, and I get an answer of about 107.2. But I'm going to do one more thing. I got to make sure I add in the 6 feet, right? Because the man is 6 feet up. So I add in the 6 feet for his eyeball and 113.2 feet, okay? And so there's your homework. It's not a lot of problems. Please try and get her done tonight, okay?
Did you do number 3?
I did not, because I knew I'd run out of time.
Okay, I thought that.
No, there you go. See, you knew I was going to run out of time, right? Yeah.
Can I take your blue test and then drop it back off?
As long as you don't show it to anybody.
I won't.
We're on the honor system here. 2 things. Don't show